Hey everyone, my name's Aaron Barsh. I've worked here at Field Environmental for about a year and a half, and I work back in our service department. I primarily work on fixing customer units. So whenever you guys have any sort of issues with your units out in the field, maybe they're not calibrating properly or just giving you some kind of weird readings, it's the kind of thing where we can send them in for service here. We can kind of take a full look and examine them and figure out what's wrong and get them back to you. Today, I'm going to be talking to you here about PIDs. So, what is a PID? PID stands for photoionization detector. These are used to measure volatile organic compounds, known as VOCs, and other gases in concentrations from as low as sub-ppb, parts per billion, to up to 10,000 ppm, parts per million. Essentially how these work is there'll be an internal pump on them that sucks air into the unit, bringing in whatever compound might be in the air. Once the compound enters the photoionization detector, it is blasted with high energy photons in the form of UV light. In this process, they emit electrons which give off an electric current. This electric current is what the instrument uses to measure the gas in whatever readings it shows on the screen. So, what are some typical applications and uses for PIDs? Mainly these are used to monitor possible worker exposure to VOCs, which can be found in the forms of solvents, fuels, degreasers, plastics, heat transfer fluids, lubricants, and more. As you might know, since this is the HAZWOPER, they are primarily used in the industrial hygiene and safety industry, and in environmental contamination and remediation, along with hazardous materials handling. A couple more unique applications that can be used for them, though, is ammonia detection and actually an arson investigation. They can be used to trace the start or cause of a specific fire in the case of arson. Let's go over some advantages and disadvantages of PIDs. Biggest advantage to these is that they're efficient and inexpensive. They can monitor a wide range of VOCs and are very sensitive, monitoring from low ppm to even ppb samples. They give you real-time monitoring, giving you instantaneous results on the screen as you go. They also include visual and audio alarms for STL, short-term exposure limit, TWA, time-weighted average, and peak limits. Last thing is that they're easy to calibrate. Most of them are only calibrated with a single gas and can be used in a wide range of applications. Some disadvantages that come along with them is, of course, they cannot measure all gases. There's a lot of things they can't detect. And they can also lose accuracy as contaminants such as dust and dirt accumulate on the PID sensor and lamp. Humidity is also another big factor that can affect these performance, but there is a way to combat that, which we'll talk about a little about later. Next, let's go over some basic tips on calibrating and maintaining your PIDs. Like we said earlier, most PIDs are typically set to calibrate with a 100 ppm isobutylene gas. Remember, it's important to always do a fresh air calibration before calibrating your unit or using it in the field. If your PID ever gets dirty from those contaminants we mentioned, it's best to just clean it with isopropyl alcohol and make sure it's completely dry before you put it back in the unit. Trace amounts of isopropyl do contain VOCs and can lead to some sporadic readings in your unit if it is not completely dry. Last step, be sure to ensure the top part of it is screwed in tight, but not too tight. You want to make sure the gold legs on the PID sensor there make solid contact with the rest of the unit. So, PID lamps. You'll hear this a lot when you're talking about PIDs. A lot of them use different lamps. What exactly does this mean? Essentially, they're measured in electrovolts, which depends on the compounds that they can detect. Higher EV lamps essentially mean they can detect more compounds with a higher ionization potential. Any gas lower than that value can be detected by that lamp. typically you'll see 10.6 EV as the standard lamp. This is mainly because they have a high resolution and typically have pretty good lifespans from around 2 to 3+ years. 11.7 EV lamps, on the other hand, can detect a higher range of compounds. However, they are a much shorter lifespan in around the 2 to 6 month range and are much more expensive to manufacture. Another thing you'll commonly hear when seeing with PIDs is the correction factor. Correction factors are basically used to allow the measurement of a large variety of different compounds while only needing to calibrate the unit with a typical standard gas, isobutylene. As correction factors are calculated by comparing the output value to set point and applying gains that minimize overshoot and oscillation while affecting the change as quickly as possible. These essentially gives you a value which is then multiplied to your calibration gas correction value to give you the value of the actual gas you're being measured. The main reason isobutylene is used as the calibration gas is because its correction factor is 1, giving it an easy time to make that equation. Remember, these are unique to every instrument and every compound that you'll find. So it's important to read your manual and know which correction factor to use. A lot of times instruments will have a built-in system for correction factors, so you just need to select it to whichever gas you're going to be detecting out in the field. Here at FEI, we carry 3 main PID manufacturers in the form of the Ion Science units, RKI Instruments, and of course, Ray Systems by Honeywell. The basic PID models we carry are the Ion Science Tiger LT or Tiger unit, the RKI 6000 PID only, and the Mini Ray 3000, which you guys are probably most commonly use. The Tiger LT has a range from 0 to 5,000 ppm, a resolution of 0.1 ppm, has data logging features, and features a 10.6 EV lamp. The RKI 6000 PID, on the other hand, has 2 different forms of resolution. It has a low range from 0 to 50 ppm and a high range from 0 to 6,000 ppm. Resolution can be 1 ppb on the low resolution on the low setting or 0.1 ppm on the high setting. It features a 10.0, 10.6, or 11.7 lamp and also has data logging features. The Mini Ray 3000, as you guys are probably most familiar with, has a range from 0 to 15,000 ppm with a resolution of 0.1 ppm up to 1,000 ppm. It has data logging features and typically uses a lamp, 10.6 EV or 11.7 EV lamp. Some of the more advanced models we carry here include the PPB Ray 3000, the Ultra Ray 3000, and the RKI GX6000 benzene specific. The PPB Ray 3000 is very similar to the Mini Ray, except in this case it can measure up to parts per billion readings. It can read anywhere from 0 to 9,999 parts per billion and has a 10.6 EV lamp included. The Ultra Ray is very similar to the Mini Ray as well, except in this case it's mainly used for benzene applications. Its PID extended range of VOCs is from 0 to 99.99 ppm, and it has a benzene-specific tube you can install in it, which allows it to filter out all other compounds except benzene, giving you accurate benzene readings. The RKI GX6000 benzene specific is very similar in the regard where it's also used for benzene detection. It has the same features where you can drop a benzene tube into the unit to filter out all other compounds and give you benzene readings. It also has 2 interchangeable smart sensor slots, which allows you to slot in other PID sensors to use in tandem with the benzene sensor. This also comes with a 10.6 or 10.0 EV lamp. Lastly, I just want to give you guys a few tips for using your PIDs out in the field, as it can be a little finicky sometimes. As I've mentioned before, water is the biggest threat for these units. The best way to combat this is to always use a water trap, which is notated, you can see in the picture there, is the little plastic piece with a little metal piece on the end. This essentially allows it to absorb any sort of small traces of water before it gets to the actual PID sensor, which can cause damage to it. Another important thing to do is to let the unit run for about 10 minutes before you actually go to take your samples. Temperatures can affect this performance of this unit, in particular extreme cold. So if you're in an environment where it's cold and you've been using the unit for a while, it's typically good practice to let it heat up or put it in a warm environment to heat it up if it's been out in the cold for a while. Another thing to note is if you're using tubing on the unit to get a sample from farther away, every half foot of tubing adds 1 second extra response time to your reading. So be sure to account for that whenever you're doing that. Also remember, always do your zero calibration before you go out and take your samples. Make sure you do this in a clean air environment, typically anywhere outside where you know there's no contaminants, or anywhere else like that. And that's all I got. That is PIDs. Once again, I am Aaron Barsh. Thanks for listening, and let's get back to the HasWhopper.